Hello everybody, I'm Nick Hoffman, Application Engineer for Oros North Americas. In this video, I'm going to be showing you a little bit about doing impact testing and different tips and tricks you can use to help expedite the process and get as good of data as possible. The force response function, also known as the FRF, is the basic result required for modal analysis, for instance. To ensure a high quality of metrology, operators can use different tools and ratings, such as time blocks monitoring, which allows users to detect any hammer double impacts which may lead to erroneous data, and coherence, which is another powerful tool used to detect non-repeatable hits or sudden failure of sensors during testing. First, we open the Select Inputs window. Activate the first input as voltage and change the label. Select force as the physical quantity. It is preferred to pick up the hammer from the database to avoid making any mistakes with the settings. A triaxial accelerometer is connected to inputs 2 to 4. We also change the input labels for the accelerometer and select it from the database. The sampling frequency can be changed with a right click on the field. The window can be extended to access more information, like the node number and the transducer's direction. Now let's take a look at the results window. From the FFT tab, we display the weighted blocks for the force and acceleration inputs to prevent any double impacts, as well as the average spectra. Then we display the frequency response function of the acceleration to the force. Save the FRFs and display the coherence of the acceleration inputs to prevent any repeatability issues and save them. Let's set up the FFT trigger for the hammer test. Input 1 will be used to trigger the FFT plugin. In the Edge Detection tab, we adjust the threshold to trigger the measurement when the force reaches 10 newtons. Now let's set up the FFT plugin for the hammer test. We change the type of windowing to uniform for all inputs. In the Trigger tab, we use the Edge 1 event created before. Put a start delay to start the acquisition just before the impact, and then select the overload rejection mode. Then we set a linear averaging and increase the number of lines. Now we click on the results overview window to check which results are only shown and which ones are shown and also saved. All of the details can be found in the Save Selection list. Now let's customize the control panel to easily access the settings that are susceptible to being changed during this acquisition. In the case of impact testing, the node number and transducer direction are updated before each new impact location. A shortcut has now been created for each selected setting. If we change a node number in the Select Inputs window, we can see that the setting has been updated in the control panel as well. When the time blocks are long because of high resolution requirements, it is useful to check the status of the current block acquisition. We can display this status in the control panel as well. Now, when we start the acquisition, a progress bar indicates that the measurement has been triggered. It may be necessary to adjust the impact threshold during a structure probing, as the surface stiffness can change. This setting can be found in the Analyzer Settings browser and dragged and dropped into the weighted block window. A shortcut can also be added to the control panel. Then, moving the threshold line in the weighted block window will update its value. We will use the auto range function to automatically adjust the range peak of input 1. After clicking on Run, we hit 2 times with the hammer to perform the auto range. The auto range function can also be launched using the keyboard shortcut Ctrl-Shift-A, and then we hit 2 times.